Chapter 2, Information. In the 1987 movie Wall Street, Gordon Gekko says the most valuable commodity he knows is information. Fast forward 30 years from Gekko's era of information scarcity, and information abundance now has stricken firms with the poverty of attention. The epicenter of strategy, not just IT strategy, is information, the stepping stone between raw data and actionable insight. The quest all along has been for foresight that your rivals do not have. When you act on something your rivals do not have, information is power. Understanding how IT can be strategic must then begin with how information alters unintentionally and intentionally how firms compete. And this is this lecture's focus. So let's go through some of the jargon we're going to use in this chapter. We're going to use the words data, information, and insight. Data is raw facts, information is contextualized and aggregated data, and actionable data is insight. We're going to differentiate between data points and big data streams. We're going to talk about analytics, which is how we use data to predict the future. Margins is the difference between what your customers pay for products and services and what it costs you to produce. Disintermediation is using information technology to bypass other firms. Value chain and versus streams is a series of bread and butter activities through which your firm creates a product or service. Its value stream includes upstream firms that it buys inputs from and downstream firms through which it reaches its customers. So let's talk about a brief history of prediction. Humans have obsessed over predicting the future since early civilization. For 1,000 years, around 8th century BC, the ancient Greeks thronged the Oracle of Delphi to hear her predictions. Since then, predictions have bounced around among common sense, nonsense, and wishful thinking. Prediction turned scientific with statistics about 300 years ago in England. During World War II, there was a huge surge in the science of prediction, and that essentially combined statistics. But business analytics, which is using data to predict outcomes of that your firms care about, started pretty recently. Predictive models are the bread and butter of analytics. The assumption that past behavior reasonably predicts future forces you to rely on historical data. Good predictions need sound data and sound models. Those of you who heard that phrase GIGO, garbage in, garbage out, essentially it focuses on the emphasis on having good data. Having good data and good models will help you predict a baseball superstar, rain, a box office hit, pricing insurance, and catching spam. Firms are getting better and better at collecting more data. We have moved from just dealing with spreadsheets to data warehouses to now huge data centers. This has led to a flurry of innovative practices on all functional areas. Firms could segment markets more finely, tier customers on their lifetime value, and forecast demand for a particular product on a particular day well enough to ensure stock. The moniker business analytics refers to this whole business of using data to predict what will happen. So here is a picture of the Oracle of Delphi. So two ingredients for business analytics data and model. First is sound data. So data is the raw material of analytics. It is raw facts that becomes information when it's sorted, condensed, and contextualized. It becomes insight or knowledge when it becomes actionable. So here is an example: 24, 32, 28. The context is that that's the temperature for your zip code, and then actionable information is whether you need a coat tomorrow, or whether what kind of clothes you need to wear based on the temperature. Unreliable data gives you untrustworthy insights. Collecting and managing data is the IT unit's job. But not all data is worth managing. Not all information it produces is competitively valuable. What is competitively valuable requires non-IT managers' judgment. Without it, IT excels in collecting more without a clear business purpose. It ends up with troves of irrelevant data which bog down business decisions, and it's the proverbial needle in the wrong haystack. Collecting more data does not necessarily result in better insights and more information. And in fact, more data could impede your insights because you're drowning in data. The second ingredient for successful analytic models is sound reasoning. Insight does not emerge spontaneously from data without a lot of energy deliberately directed towards transforming it. Here, this is where software applications are used to transform data into information and then into knowledge. Applications are models translated into software codes. Now, those of you who took the 710 class, that's your analytics class where you're converting data into information and knowledge. Predictions are only as good as managerial insights in underlying models. And these could be function specific, focused on marketing, accounting, finance. And non-IT managers are the only sources of this sound reasoning. And they are help in predicting things which are worth competitively. And these models focus on functional domains, so you need some functional knowledge for you to build these models. So before we get into big data, let's talk about the evolution of data or data analysis. For a long time, we lived in an era of information scarcity, and we developed tools which we call statistics, we call linear programming, nonlinear optimization, forecasting to deal with scarce data. These were built-in disciplines called operations research. If you're an engineering or mathematical field, or if you're in business, we call them management science or decision sciences. And all the way till the 80s and early 90s, we really focused on this information scarcity. But with the increase in computation power, digitization, now the infusion of software into products and the connectivity, the whole ubiquity, big data is just not about volume or quantity of data, but there is a qualitative difference. Data points, static data points, are being replaced by ephemeral big streams of data. Ephemeral means that these are continuously flowing data points and they last for a very short time because its volume far exceeds our capacity to store it. If you do not use it within a brief moment, you lose it. Streams mean that data is continuously flowing as a series of data points. So as an analogy, think of data points as a lake and data streams as a waterfall. And the skills you learn to maybe boat row skills in a lake will not help you navigate Niagara Falls. So our IT's historical focus has been focused on dealing with data points. So the digitization, infusion, ubiquity trifecta perpetuates these data streams. We're getting data from interconnected supply chains, from mobile devices, social media, Internet of Connected Things. To give you an example, Walmart produces 200 times the entire content of Library of Commerce every hour. Boeing 787 jet generates 40 terabytes of data, which is worth 2,500 iPhones, which would take 2,500 iPhones to store it. Most firms fail to capitalize on the data on hand. Uh, Abundance and not scarcity is the problem. And if you remember, our IT systems and our tools have been derived to deal with scarcity and not abundance. So abundance can be disorienting to managers who have been working with information scarcity because it removes traditional, your familiar trade-offs. Now the strategy must be crafted for assuming information abundance instead of information scarcity. This raises the bar for what is valuable insight, and this kind of translates into the Red Queen effect. You had lumber companies who historically treated sawdust as a waste until someone figured out how to turn it into particle board, synthetic wood, and snow traction material. This spawned entire new industries, with IKEA's $40 billion a year business at the helm. The sawdust of our era is data. Every time a piece of software runs, it generates data as a bright byproduct. The trail of clicks you leave behind is no longer worthless byproduct, but can be mined for insights to shape products and services, optimize operations, and develop new business models. Analytics is a baby step in repurposing historically wasted data to create business value. Big data is creating two types of opportunities for a firm. One is replacing prediction with foresight, and two, offering insights into what causes what. So opportunity one is generating foresight instead of prediction. An entry-level iPhone in 2017 had the computing power of 100 Cray supercomputers in 1980s. Cheap computing power is shortening the lag between arrival of data streams and their analysis. And as this lag approaches zero, analytics is becoming so real-time that prediction appears to become foresight. Data streams from all sorts of connected devices, such as your phone or your car, also provide contextual data of where you are, where you have been, and what you did a moment ago, and where you are going. And that's called location analytics. This opens up unprecedented opportunities for real-time foresight into how your firm can create more market value. For example, it enables finer-grained micro-segmentation of the markets, dynamic pricing, and instantaneous price discrimination. Example, changing the asking price to what you predict a particular customer will pay. Now, Amazon has already tried this, and there was a huge backlash, so you want to be careful on how you use this data. The business challenge is imagining how to consume such foresight to deliver more value. Opportunity two is understanding causation. Traditional analytics used correlation, which you know from your statistics coursework. Two things move together beyond reasonable doubt. Statistical significance indicates this. You do not know what causes what and often do not care why. For example, there's a very strong positive correlation between beer sales and diaper sales. And Walmart, for example, stocks up on diapers on Friday because it knows that its sales correlates with beer sales on Friday nights. To exploit that insight, you do not need to know why. However, causation is the holy grail of prediction. we can tweak things that cause sales, returns, reduce returns, and increase customer loyalty. So remember, the first part of causation is association or correlation. The second part is time order, which is the thing that causes the other has to come first before the other. And then the third one is that it should be non-spurious, which spurious means false or not genuine. A relationship between two variables is spurious when it is actually due to changes in a third variable. So what appears to be a direct connection is not in fact a connection. Okay, so this is essentially goes back to correlation does not show causality. Very often when you listen to TV pundits, they're often talking about correlation and not causation. Again, the trifecta of digitization, infusion, and ubiquity opens up excellent opportunities exclusive to digital firms. These digital firms are like Facebook, Amazon, Google, and they are collecting a lot more data than traditional firms have been able to.